Okay, number 7 is asking a car travels over a hill at a constant speed. If the radius of the hill is 30 meters, at what speed would the centripetal force equal the force of gravity? If the car was to exceed the speed, what would happen to the car? So we can start off by drawing our free body diagram. And since the car is at the top of the hill, we know force of gravity has to point downwards and normal force has to point upwards. And then using our equation, we know that the centripetal force has to point to the middle of the circle. So we get Fg minus Fn equals the net force. And then that would also equal the centripetal force, so mv squared over r. And then it says that the centripetal force has to equal the force of gravity. And the only way that happens is if normal force is 0, because Fg minus 0 equals Fg, just Fg. And so we get Fg equals mv squared over r. So that's why normal force has to equal 0 over here. And then we can change Fg, force of gravity, to mg, and the m's cancel out. And then we plug in the radius, which is 30, and we multiply r by both sides, so 30g equals v squared. You plug in the 9.8 or 10 for g, and you take square root and you get 17.3 meters per second has to be the speed.